Hey math kids, today we're going to talk about perpendicular bisectors. We are in section 1C in your book, and there's just one example to go over. So we are given 2 points, A and B. So we can draw this however we want. So B would be there, A would be over here, and we're asked to draw a perpendicular bisector. So what we need to do first, we need to find a midpoint, because definition of midpoint is the point on a line segment that cuts it perfectly in half. So in other words, B to this point P would be the same length as P to point A. And the second part is we need to make sure that that line that cuts it in half is perpendicular, which means it makes a 90-degree angle. I know that doesn't look very good, but it makes a 90-degree angle. So let's focus on that first part of the definition. So we need to find the midpoint, and you may have this memorized. Whoops, that's not what I wanted. This is the midpoint formula. You can have that memorized, and that's fine. I actually like to just think of midpoint as the average of the x's and then the average of the y's. So I'm just going to add the x's. It's 4 plus negative 2, or 4 minus 2, and we just get a 2. And so it's 2 over 2. And then we have negative 3 and 7, so that's going to give us a 4. And that's over 2. And so when we simplify those, we get 1, 2. Okay, so this is our midpoint, or this is point P on our diagram, right there. And so we know where the line is going to cross to make it a bisector. Now we just need to focus on how do we make the bisector be perpendicular. So you're going to have to think back to some stuff that you already learned, but when we have perpendicular slope, we need to do the opposite reciprocal. Before we can do that, though, we need to know what the slope is of the original line segment. So to do that, we bring up our y2 minus y1 over x2 minus x1 slope equation. And we plug those in, so I'm going to call this x1, y1, x2, y2. So we start with y2, which is 7. Then we subtract y1, which is negative 3. And then we take x2, which is negative 2. And we subtract x1, which is 4. So right here, double negative is going to be a positive, so we get 10. And then negative 2 minus 4, we get negative 6. And if we simplify that, we will get negative 5/3. Just divide the top and bottom by 2, and then the negative should come up top, or at least stay in the middle. So this is our actual slope. This is the slope of this segment that we create right here, but we want to get the perpendicular slope. And so what we need to do, we have to find the opposite reciprocal, which just means we flip it upside down and change the sign. And so if we flip it upside down, it's 3/5, and since it was negative before, now it's positive, and this is our perpendicular slope, which sometimes is written with that upside down capital T, showing that it's perpendicular. Okay, now we know a point that it passes through. We know the slope of that bisector because it's going to have a perpendicular slope right here. And so we can just plug that into point slope form, which is y minus y1 equals m times x minus x1. And we just think of this like our x1 and our y1. So new color so we can see it. Y minus 2 equals the slope times x minus 1, right from up here. Okay. Now, technically, this meets the criteria of the perpendicular. It is an equation. It's in a valid form. Your book, for some reason, takes it all the way to general form, but the question doesn't ask for it. But just if you're wondering, I will take it to general form as well. In our class, though, this would be acceptable for this question, and you could stop there. Now, if you want to put it in general form, first you need to distribute right here. So we get 3/5 x minus 3/5. We still have our y minus 2 on this side. And now, since it's general form, general form is ax plus by equals c. So we need to get our x's and our y's on one side and our constants on the other side. So we subtract 3/5 x and we add 2. So this stuff is what we have here. So negative 3/5 x plus y. Those cancel. Those cancel. And this, we're going to think of the 2 as a 10/5. So we have a common denominator, which leaves a 7/5 right here. In general form, 2 things. We can't have fractions for coefficients, so this doesn't work, and we don't want to have negative. So what we're going to do is we're going to times by -5, all the parts by -5. So this negative cancels this negative, 5 cancels the 5, so that's just 3x. -5 times y is -5y. And then the 5 cancels the 5, and it's negative times 7, so -7. Okay, so that's what the book ended up with for their answer, but like I said, there's nothing that says we have to do it in general form. Alternatively, if you wanted to solve this for y or solve this for y, you could get it in slope-intercept form if you like that better. That's all we have for this video, so calculator.